this one really kind of sticks out as tricky because we know what we're doing here. We know we're looking at a triangle. And from that triangle, we're going to be subtracting a circle. We know that going in. And the circle is easy to get. It's pi r squared. That might, right there, that may have solved at least 3 people's problems. Because so many of these other problems involved so adding the pieces together, whereas this is a subtraction problem.
Oh, I got it right.
Sweet. So 36 times 3.14 gives me 113. Pretty darn close. So I'm just going to call it 113 to keep the math easy. Now that's just the cutout piece. I still have to deal with finding the area of the original token that I've drilled this hole in. And that's a little challenging because for a triangle, we usually want base and height. Now there are 2 ways you can approach this. The harder way, but better practice, is to look at it as, find the apothem, and think of this as a regular polygon with a side of 36.
You gotta find an angle. No.
Yeah.
That's the easier way.
The easier way,
We like easy.
this is 36 here. This is 36 here. So how long is this distance from here to here? 18. So according to the Pythagorean theorem, 18 squared plus, call it x squared, is 36 squared. Now a common mistake, guys, gentlemen, is to think, oh, hey, I've got 2 out of 3. A lot of students doing the Pythagorean theorem are going to go right ahead and they're going to say 18 squared, 36 squared, x squared. Because so often we're looking for the hypotenuse. So watch for that kind of mistake. Don't be that one. So let's get to some numbers here. 18 squared puts me at 324. 36 squared, I should know that one, but I don't. It's 1296. There's my x squared. Take off my 324. And then take the square root of that. And I get x is equal to 31.2. Yeah, yeah. The whole bottom is 36. I'm only dealing with half of it. So now I can go ahead and get I'm going to work over here in this space now. The area of this triangle is half the base, which is 36, the whole base, times the height of 31.2.
561.6.
561?
Why wouldn't we?
That seems kind of high.
1/2 a. Yeah, but you have to subtract it from 113.
Oh, that's right. I'm going the wrong way. I'm like, no, because we're adding, because I was doing the same thing you are. So what'd you say, 500? Oh, here.
561. That's what I got. Maybe
Yep.
I'm wrong.
Yeah, you got it. 561. Technically 561.2. And then from that, I'm going to subtract, in case there's any doubt there, my 113. And that's where I get my 448. Technically, the answer's listed as 0.1. But, you know, we're off. If you're off by 1/10 with the numbers we're working on, I call that pretty good. I'm not going to lose a lot of sleep on it. What you got for me? If you're going to go the apothem route,
Wait, just get a whole new sheet. It's gonna look messed up.
it'll look just fine.
Forward.
Boom. Boom. That's just going to be 120 degrees, which makes that right there 30 or 60. So your apothem is going to be based on 18 units here, 60 degrees here, and then what's this? Still didn't get that? Okay, I'll check yours later. Because we can do that, but I don't want to get too hung up on that because for a problem like this, you're really better using the Pythagorean theorem than trying to bring tangent into play.
Why?
What did you get for the apothem?
10.4.
Let me check that number real quick. Let's see, 18 divided by the square root of 3. Yeah, that's right, 10.4. So that's using tangent. Oh, what the heck, let's finish it up while we're going. 10.4. So according to the big line, because it's a separate part of the problem, the area is 1/2 the apothem, 10.4, times the perimeter, which is 36 times 3. 36 times 3 is 36 times 3. I'm just not that sharp this morning. 108. And then that should give me my my 561 when I'm done. Now, if you got the wrong answer, you want to double check to make sure you still subtracted the 113. I'm off?
No.
Okay. Why is what?
Why is it 108?
Because it's in the apothem formula. Remember, it's half apothem times the perimeter. The whole figure, yeah. And usually the perimeter is the length of one side times the number of sides. And I know we need to practice these more. That's part of my plan for tomorrow, is to take another good look at
No, I got
the apothem areas.
I feel like you're holding a Wii remote.
Okay.
So, like, if you didn't use the apothem formula to find the area, and you just use like area equals 1/2 base times height,
Yeah.
you would have had to multiply 10.4 times.
No, that's the problem.
No.
If you do that, the apothem is not, the distance from the apothem up to this point here. This is not the midpoint of this segment.
So how do you?
That's the catch. If you use the apothem and then you doubled it, that doesn't actually tell you how tall the triangle is. It just doesn't work out that way. The apothem and the diagonals are different measurements. So, and that's a common mistake to make, and it looks right too. So I'm kind of glad we had that problem, because that's a good one to have to deal with.